All right, so for version 1 of this particular file, in fact, let me run this thing off. So if you want to see it, you can. All right, and again, I don't think there's any mistakes on here now. So I'm running off 10 copies of that right now. But the first example of this, or the first thing that's in here, I'll bring this up. Again, it's functional in that the interface is built. It's not functional in that none of the buttons are programmed to do anything. All right, so there's no code in it whatsoever. So you'll see it come up in just a minute. I made the background blue. The buttons are all black. The text in the buttons are all black, etc. Steps again are right here. So again, for iteration 1, which is in that folder under just calculator, right, these are the steps that I used in order to put that stuff in. All right. Again, there's no code in here whatsoever. In fact, if I go over to the viewcontroller.swift, you'll see that the only thing that's in there is the stuff that comes by default with the system. All right. So this is what we created based on those 13 steps that you see in front of you. All right? So that was iteration, version 1, whatever you want to call it. All right, from there I went on to version 2, which has code in it. So I want to go over that, and then I want to go over version 3. Ideally, I'll get this done by 4 o'clock, and then you've got an hour to sit and work. And since it's due Thursday, I was going to make Thursday, it was just going to be a lap day. All right, so hopefully people, if you are behind, you can catch up. Again, really and truly, it's not my intention. I don't want to hear, yeah, Jeff, thanks for screwing up my spring break because all I did was homework. All right? And my guess is if that's the case, then maybe you put it off. And I'm not saying you did, but if you did, there's not much I can do about that. Oops. All right. So again, there's the interface. So what I want to do is go in and talk about some of the code. Again, you have all this code that I'm going to talk about with you already. All right, so taking it from the top then, and taking a look at the code that you see in here, you'll notice that there's 3 variables. The first variable is an IB outlet. In other words, I control drag from here to there to create that one. Now, my hope is by now that makes sense as far as what we're doing. We don't have to talk about it anymore. All right? Now, what I do want to mention, because I don't know how much I've talked about this, and I'm by no means an expert on it, but you may or may not have noticed that when you put that out there, you automatically get that exclamation point. All right? And what that exclamation point literally stands for in this language, it means that's an explicitly unwrapped variable. In English, what that means is if if you are expecting something to be in that value, all right, and you have to use it in the program, and there's nothing in that value, the program's going to blow up. Does that make sense to people? All right. And what happens when you first set up a label if there's absolutely nothing in it? If you set up a label like that and there's absolutely nothing in it, you literally can, if you want to, you could go in there and we could initialize this, because this is what the system does. It sets that equal to nil. Now, hopefully you realize this. I moved off the line, and it didn't give me an error. That's what the system does for you, because this is such a type-safe language. And since it's expecting a value to be put in there, and you haven't put anything in there yet, it automatically sets it equal to nil. All right? And nil basically is an unknown. It's like null. All right? But it's doing that to protect you. You don't have to do this. All right? It's done for you automatically, is what I'm saying. All right. Now, this is just a little bit wider. That's why it's wrapping right here. That's why the label holding input answer, etc. Now, the second one is a Boolean variable. All right? And it's is user typing number. Okay? Which is pretty explicit, pretty specific as far as what's happening. In other words, think about this. If you've got a calculator and you're running it, one of two things is happening. Either you're entering a number, or you've entered a number and you're about to enter an operation or something else. All right? So if you're still in the middle of entering a number, so let's say I want to enter the number 987. All right? Right now what's in there is just that 0 because nothing's been put in. I type in that 9. Okay? That means is user typing number should now be set equal to true. That should make sense to all of you. All right? I put in the 8. It's still set to true. I put in the 7. It's still set to true. All right, on a regular calculator, if I press plus, then now it should be set to false because I'm not entering a number anymore. This is a stack calculator, so the way, if I want, let's say I want to take 987 and I want to add 73 to it. The way that I do it in this program is I put in 987, I hit the enter key, I put in 73, I hit the enter key, and I hit plus. And that will add the two up, and it'll put the result on the stack. You'll see this in just a couple minutes. I'll show it to you, all right? The last thing that's in here is what we're putting on here. All the values that we're going to push on here, I set it up, and I set it up as an array and an array of doubles. And you might say, well, why'd you make it doubles? There's no decimal point there. This will handle doubles. Now, you can't explicitly put doubles in yourself, but for instance, if I put the number 5 here, and I hit that, that's going to definitely be a number that's going to have a decimal place in it. All right? So again, these are the three variables. The one I don't think we have to talk about anymore. And then we've got these other two right here. All right? The syntax for creating an array like that looks a little bit funky, but that's the way it is. All right? Now, have you all noticed this by now? Hopefully I've said it, but just in case I haven't, if you look over here where it says IB action func append digit, see there's that little dot over there? All right, maybe you've noticed these before, maybe you haven't, but notice if I take my mouse, or my cursor I should say, and put it over that dot, see what happens? It shows me everything that's wired up right there. All right, and what it's showing me is, you can't read them very well, but 7, 8, 9, 4, 5, 6, 1, 2, 3, and 0 are all wired up. And they're all wired up to this. And think about this. Sometimes you see calculators, and they have literally, you've got a different function for entering a 0, and entering a 1, and entering a 2, and entering a 3, and entering a... That's 10 different functions that are really doing the same thing. The only thing that's different between them is, in this case, we're having one function to handle everything, and that you're having separate functions for each number. All right, I think this is a better way to write the code. You may or may not agree with that. All right, and the reason I'm telling you that is up here it says sender UI button. Well, the way that the system knows which one of these is being pressed, all right, is because the sender. So if I hit this one, the sender is the 4. That makes sense? All right. So if we want one routine to be able to handle multiple controls, we have to, in here, pass some kind of a parameter to let it know how we're going to do that. All right. And the reason I'm telling you that is take a look down here. Func enter, paren. Because that one handles this. Just this. Since it handles just this, we don't have to put in there sender UI button because there's only one thing that this is in regards to, for lack of better words. All right? So we come in here and we say let digit equal sender.current title. All right? Sender is whichever button it is. Title is the 4 or the 5 or the 6, etc. So that's how we're scraping off whatever we put in there, for lack of better words. So again, the idea is if I'm sitting in there and I'm running the program and I enter 987 and I hit a 9 in there, all right, then digit is going to be equal to that 9. Then it's going to see, am I currently entering in a number? Well, if I'm not, if it's the first time I've started entering in a number, then this isn't true. So I just say, okay, just display that number and set is user typing to true. So now I come in and I type in an 8. And it comes back up and it says, okay, grab that. Is user typing number. Remember, that's a shortcut for is user typing number equal true. Well, now it is. So I'm saying add that digit to whatever I had before. So instead of having the display text up here, instead of having it be equal to 9, it now equals the 9 plus the 8 that I just put in. All right. Now, I found errors in this since I've done it. I'm going to show you what those are in just a minute, too. All right. Does what's going on in here make sense? I put some print lines in there, and if you uncomment these, what you're going to find is down in your console area, when you run the program, you'll be able to see everything that's happening. Okay? All right. Then we've got this enter function. That's now right near the top. All right, and again, if I take my mouse, or the cursor, I should say, and put it right there, you'll notice the only thing that lights up is the enter key. Now, that might not be a really good enter key that I chose. I just grabbed that finger that was pointing to the right here. Okay? But that's right here. In order for this to work, right here, in order for this to work, this needs this, just so you know. So this needs this in order to work. Remember, this is a type-safe language. So ideally, when I hit enter, ideally what's going to happen, so if I put in 987 and now I hit enter, there's 987 in here, correct? Does that make sense? What I want to have happen is I want that 987 that's in here, I want that to go into my array that has all the different things that are on the stack. All right? So I want that, my stack, which currently would be empty, I want it to now have in 987.0 after I do that. The problem is, that's a stack that holds doubles. This, regardless of what you know, and you all know this, those are characters. And there isn't a magical, easy way to just go and change something into a double. Well, you can cast it. You can do this, yeah. There are different ways that you can do it. Some work better than others do. So this gave me the chance to talk about something that's built into the language that's called a computed property. All right? And I put the URL right there for where the computed property is discussed. What is happening right here is we're creating a brand new variable right here, and when we get done, we're stuffing it in there. All right? And why are we doing that? Because that's a double. So now we have no problem putting that in there as a double. Okay? So in order to do this, looks a little weird, var, the name of the variable, colon, the type, and then a get and a set. Sound familiar? Those of you who were in the Java class, you've done gets and sets before. It's a similar type of thing. Let's talk about the set first. It says display.text equals double quote, backslash, new value in parens, double quote. What the hell is new value? It's literally, it's a magic variable that exists in this language that's available to you. All right, that's the best description I can give you. So what we're saying is, okay, what we want to do is we want to grab that, and basically we want to set whatever's in there equal to new value. And then we want to let the user know we're done typing. All right, we should be done typing because we just hit the enter key. So we're not typing in a number. All right, so the is user typing number, we're making sure it's set to false. We are very responsible as we're going on in here, for things like these Booleans, etc., to make sure that they're turned on or they're turned off. We have to do it. The system's not going to be smart enough to do it for us. All right. Then in English, and this looks pretty doggone ugly. I don't know if you agree with that, but I think it does. An NS number formatter, dot number from string. This is why the people from Apple say that, when people ask, well, should we learn Swift? Yes. Should we still learn Objective-C? And if you listen to them, they say yes. Because what that is, that's an Objective-C function that's being called directly from Swift. All right? And in English, what it's saying is, take what's in there, convert it over to a double, and return that and put it in here. Now, that wasn't the greatest of explanations, but again, you can start to get a little bit more attuned to what's going on by going over to that URL that I put there. But the idea is we want to take whatever we put into that label, which is automatically text, string, characters, whatever you want to say. We want to convert it into a double, and then we want to throw it into here. And that's what we're doing right there. All right? And again, I'm going to run this in just a minute, and you'll see it. Yes.
After your close paren on that line displayed that text, exclamation point.
Yes.
There's another
yes.
Exclamation point.
Well, the smart-ass answer is you got to do it like that to make it work. All right, but you're doing two unwrappings. That's why.
Okay.
All right, you're doing one unwrapping here, that display.text. But then you're unwrapping it again for its double value. Right? And that's the only explanation I can give you, and it's not a great one. Right. So the next thing we want to do is we want to wire up our operator. And again, if I put my cursor up here, notice what that's hooked up to. So that is the plus minus, the plus, the minus, the multiply, the divide, and the square root. Now, do we have to do it like this? No. All right. Is the way I did it the best way? No. In fact, I'm going to change it in the next version that I show you in just a minute. Hopefully, one thing you'll understand is when you look at the plus, and the minus, and the multiply, and the divide that are here, all four of these have the exact same code in them. The only thing that's different is a plus sign, or a minus sign, or a divide, or a multiply, or a divide. Other than that, they're the exact same code every time. That's why it'll be rewritten for the last iteration of this. All right? So what this is saying in English is, I want to add something. Well, I have to have at least two things if I want to add them. All right? And if I want to add them, grab the last two things that are put on the stack. So let's imagine that I typed in 987 like I showed you, and I hit enter. Right there. Okay? Now, I type in 453. So I've got 987.0, and then I type in 453, and I hit enter again. That's what the stack now consists of. All right? So if I hit the plus sign, right now, if I hit the plus sign, so I've done both those. 987, enter. 453, enter. Plus, enter. All right? It's going to add those two up, so of course I couldn't have taken something easy if I did my math right. What that's going to do is it'll now show here. Does that make sense? We just told it to add those two things together. It did exactly what we told it to do. And you can do multiple operations. I can, for instance, I can put in 5 different numbers. 78, enter. 89, enter. 56, enter. 23, enter. 32, enter. And then start putting in operators if I want to. That gets very confusing, but you can do it. All right. So now I put that in. Well, now if I went in and I typed in, for example, if I hit the enter key or a plus and enter, nothing's going to happen because I only have one thing in there. So I'm going to come in and I'm going to add something else. I'm going to put in here 32, and I'm going to hit enter again. So now I've got in here 1440 and 32. All right. Now I come in with those two, and I've already done the plus, so I do a minus. Same kind of an idea. It's not going to give you what you think it is. All right, because the way this is written, it's supposed to take this one and subtract from it that one. So I'm going to get a really big honking negative number. That makes sense? I'm going to get, instead of 1,408, I'm going to get negative. Because it's instead of taking this one minus this one, no, it does it from the end. So it takes 32.0 minus 1440.0. And it gives me that answer, which isn't going to be probably what I want. All right, but there is another key up here that says plus minus. That will change the sign. All right, so now instead of being negative, so when I get done with this, this will be negative 1408.0. So after that's what it'll be after I do this. So after I hit the plus minus, it'll now be 1408.0. Does that make sense? All right. And I can go through and keep doing the same stuff. Let's suppose that right here, I'm just going to take for granted that the multiply and the divide are going to work. All right. So what I do next is I hit the square root key. Well, now I'm going to get the square root of 1,440. I don't know if that's 120 or not, but it's probably pretty darn close. Okay. So that's going to give me something like this. Does that make sense? We're going through the mathematical operations. All right, I'm going to try to replicate this in just a second to see if I was right or if I was wrong. Okay, but again, what I'm trying to show you here is this for the plus, this for the minus, this for the multiply, this for the divide. All right, and let me move that down a little so you can see the divide also. So if you notice, they're virtually identical to one another. The only thing that's different is the sign. Everything else is the same. So we'll fix that in the next iteration. All right? And then what's left? Well, we got the plus minus. Okay? So it says, as long as there's something in there, if operand stack dot count is greater than or equal to 1, in other words, if there's something in there, and here there is, right there, all right, then set it equal to, it's negative. All right, I could have multiplied it by -1. There's a lot of ways that you can do that. All right, but I just kept it simple. So that should hopefully convert this into this. All right, so when I come down and I do the last one that's in here, which is that square root, I'm just calling the system square root method. And this is one of those languages, Swift is one of those languages where the system supposes that whatever you put in here and you're going to do the square root is a double. That's why I made these doubles. All right. So the only thing that's left in here is the clear. Here's where I've got an error in my code. I'm going to show it to you anyway, but this is where there's an error in the code. All right. These two things right here could have been combined into one case statement because they're doing the exact same thing. Does that make sense? Every line here and every line here are the same. The difference between CE and C is if you do decide you're going to put a memory function in here, CE, all right, CE clears out the memory. C just clears out what's up here, basically. All right. But I set them up as two in case you wanted to do that. This is the one that became a pain in the butt, and that's where my error is. So I'm going to show you that. Let me put as much of it on the screen here as I can. And I'm not too proud to say that when I'm not sure of how to do something, I'll go out and look, and I did. So I went out to my good friend Stack Overflow and found out how to get the nth character of a string in Swift. All right, and I used basically what they have there. The idea behind this is every time I hit this, so again, play computer. I put in there 987. I hit this. Now the 7 should go away and I should have 98. I hit it again. Now the 8 should go away and I should just have a 9. I hit it again. All right, I hit it again. Now the 9 should go away and I have just a 0. That all works. Problem is, right now there is a problem with it. The problem is, what I should have checked is for a number less than 0. Because what happens is, if this is my label up there, and I've got negative 987.0, this works. It removes, in fact, I think it will look just like this. Removes it, it removes it, it removes it, but then it tries to treat that like a number, and it blows up right there. All right, and I should have handled that. I didn't. All right, no excuse, I didn't. So let me run this. It's like an equals, but it's not an equals. If you want on yours, you could make it into an equals, all right? What I liked about what this gentleman did, and I gave you those URLs last class, all right? Now I think the first 8 of them are out there on the system. He's done like 14 lectures, and I've watched like first 2, and I'm in the middle of the 3rd one, all right? I mean, this guy, he sits there, and he just does all this off the top of his head. I wish I was that talented. I'm not. I don't know about the rest of you, but I'm finding it might be my machine as opposed to your machines might be different than this, but I can let this sit and sit and sit. But if I haven't run this simulator in a while, it's just not going to come up. Literally. I can give it 10 or 15 minutes. It's not going to come up. But what I found is when I stop it, so when I quit, and then I come back and run it again, normally the 2nd or 3rd time it comes up and it's a lot faster. And it actually runs. Now, I don't know if you've had the same thing happen to you or not. All right? This morning it took 4 tries, and then it worked like a charm after that. It's funny. I joined the study group for these people at Stanford. Do I contribute anything? Hell no. But I like to read what they have back and forth. Now a guy from India wanted to friend me yesterday on Facebook. I went out and looked, and I looked like it was India. I hope he's not a member of ISIS or anything like that I'm going to get myself into trouble. But he had some name I can't even pronounce. It was like not Goopy or something like that, and the last name was harder to pronounce than the first name. All right, so here it is. So looking at what we had before. 9, 8, 7. You see the numbers up there. Enter. There's my stack right there. If you look at where the mouse is, right here. All right, that was just a print line that I put in there. All right. 4, 5, 3. Enter. Now you see those are both on the stack. All right. Plus. Exactly what I've shown you so far, right? Okay. So now I'm going to go, and so what I'm doing there is I'm pushing stuff onto the stack. All right. So I've got that. Now I'm going to put 32. Enter. And now I've pushed that onto the stack. All right. Now, though, when I do a minus, instead of saying 1440 minus 32, it says 32 minus 1440. Okay. So when I do a minus, I get that number. Okay, so I do my plus, minus, and I've converted it. The old one is still there. Should have gotten rid of that, I guess. But that one's now it's positive. So if I go here now and I hit my square root key, all right, I'm getting a number 37 point something. Now watch what happens. Okay, I'm going to purposely introduce an error in here. So I'm going to say plus minus. Now I made it negative. So I'm going to start hitting my backspace key. And it looks like nothing's happening, but it is. There's like 15 or 16 digits in here. Everybody see what's happening? Now, when I do it again, it's trying to format that into a number. It's not the fact that it's negative, it's the fact that's a non-digit. So what I should have done is when I got to the end, if the last character was a minus, I should have checked for that and did not. So the program has a flaw in it. So when I click that, it blows up right there, letting me know, hey, there's problems over here, and it's unexpectedly found nil when unwrapping optional value. That's on me. I shouldn't have done it like that. All right, I should have checked. So if you decide you're going to use what I've started here in yours, you should fix that. All right. Again, last thing to tell you quickly here is, as I mentioned to you, if you look at the stuff that's over here, you'll notice that the stuff for minus, multiply, divide, and add, etc., subtract, it's almost the same. So if I come in here again and I close this project, all right, let's close this. And if I bring up version 3 of this, you're going to look and you notice the storyboard looks the same. And that's crud. I don't understand this. That's got the same one in there. Now, everybody sees that? The stuff that's up here, this is the same. All right? It shouldn't be. Now, I want to show you something. Here it is, on here. This is the same one that I showed you before. There's 3.3, version 3, calculator. All right, view controller. I know you don't see it up there. I understand that. I understand. I can go back. But the thing is, if I go back right now, then I lose. I can't tape anymore. All right. But what I'm going to show you, I'm going to do this. And I'm just going to do the selection. Okay. This will literally just take a minute to do because I want to be done with this, like I said, around 4. Those of you who were in the class, was that last semester? I don't even remember anymore. Was that last semester when we went over that real big book that I gave you from Apple? I think it was. One of the things, I gave you the book though. One of the things that was in there, it's that collection of pages. Yeah. All right. One of the things that was in there talks about closures. All right. What you get when you develop a closure, and I should have actually probably showed you a few more pages than this, but I'll show it to you after the break. That where we're switching to do the plus, the minus, etc. Tell me if that's a little cleaner. And when you look at that code, the $0 and the $1 represent arguments. All right? So I'm saying add the first argument to the second argument. Here I could have actually flipped these around and I could have said $0 minus $1, But the two here on this example that I just gave you right there, the two here that matter, all right, are subtract and divide. That's when order matters. All right, that's why putting the $1 first does matter. All right. Now, you can't, you say, well, that sure didn't seem very hard, you know, doing that, etc., sure didn't seem very hard. It wasn't very hard. But in order for us to be able to do that, we did have to add a little bit more code. And what I can't understand for the life of me is the one that I'm showing you up on the screen right here, where the code looks the same, that's the same one that I gave you this from. And I don't see it on there. So weird things are happening. All right? But what I'm going to do, it's 3:57. I'm going to go till 4. So what I'm going to do is I'm going to stop taping, and I'm going to switch back over to this one and show you what I wanted to show you on here, where you just got the handout for. All right? But in order to do that, I have to stop taping because I'm going to break my connection then. And actually, let's do this. I don't want to take a chance. I don't want to ruin this tape.